Today we're going to take a look at finding volume using what is called the shell method, okay, cylindrical shells. We use this mainly when we are rotating around a vertical axis of some kind, whether that's the y-axis or an x equals line. The reason that we can do this, the surface area of a cylindrical shell or a cylinder is 2 pi RH, with, of course, the 2 pi r squared being the area of the bases, which is not what we're looking at. We're looking at the outer shell of that cylinder. We're thinking of cylinders filling up this. Again, I linked a video animation for you to look at if you're trying to get an idea of what these look like and why we can use this. But the nice thing is, for shell method, we only have one formula, integral of 2 pi RH. And again, the 2 pi is just a constant, so we can put that out front. Okay. A couple of things to note. If you are going around the y-axis, your r is always going to be x. If you're going around an x equals a number line, so x equals 2, x equals 4, something like that, then your r is always going to be, your r is always going to be that number minus x. Okay, think about why. If our radius, say we're rotating around 2, okay, and we need to go to the area. Okay, we got to go to the area. Well, actually, let's pretend we're going around, because that'll make this a little easier to see. Let's say we're rotating around 3, and we need to find the radius. Well, the radius would go to wherever the function was, right? Okay, wherever the function was. So we're talking about 3 minus whatever the x value is to get there. Okay, if these are the points x, y, then we would have to subtract the x value to get that radius. And so that's why the radius, when we're going around an x equals a number, like x equals 3, a radius is always that number minus x. Okay, unless we're going around the y-axis, in which case the radius would be going from 0 out to the area that we're looking at, which means the radius would be x. Okay, those are kind of nice because it's a little bit easier to see what's going to happen depending on your problem than with disc or washer method. Your height, no matter what kind of line you're going around, your height is always that upper minus lower. It harkens back to our area, finding the area between curves. We did upper minus lower. Same thing for height when we're using shell method and going around a vertical axis. We always have our height be the upper minus the lower of the area that we're looking at rotating. All right, let's take a look at some examples. Okay, some of these might look familiar. We've done these with disc and washer method going around a horizontal axis. Now we're going to go around a vertical axis. So let's take a look at the first one. We have the region bounded by y equals 2x. That's just a linear function. Slope of 2 goes through the origin. Y equals 0 is the x-axis, and x equals 3 is a vertical line. And we are going to rotate around first the y-axis. So we're going to use shell method. So we want to have 2 pi times the integral. We need our bounds. We're going from 0 to 3. Okay, we need r and h. R is always going to be x if we're going around the y-axis, remember. Height is upper minus lower. Upper of this area would be 2x. Lower would be 0. So 2x minus 0 is just 2x. So we have x times 2x. Okay, if we go and, excuse me, let's do this without the pi. Okay, x times 2x, comma x, comma 0, comma 3. Okay, that's going to give us 36 pi. Okay, as a decimal, let's find that. That would be 113.097, okay, for our first one. Now, for part B, we want to go around the line x equals 3. So remember, when we go around an x equals line, our radius is going to be 3 minus x. Our height is still going to be 2x. The height doesn't change. So now volume is 2 pi times integral from 0 to 3 of 3 minus x times 2x dx. Okay, I'm going to do this again without pi so that we can get both answers. Let's see, we have 3 minus x times 2x, comma x, comma 0, comma 3. Take that integral, that gives us 18. So that's 18 pi. And then as a decimal, 18 pi is 56.549. Okay, so that's our volume rotating around x equals 3. Okay, again, shell method, in my opinion, is very easy. Okay, so I like the fact that you have kind of rules for your radius and height. It's a little bit harder when you're looking at disc or washer method and figuring out your big R and little r if you need it for washer, whereas with shell method, a little bit easier. Okay, let's take a look at this one. We have the region bounded by y equals x cubed, y equals 8, and x equals 0, which is the y-axis. Okay, so let's think about this one. That's our area. This is at y equals 8. 8 meets x cubed when x is 2. Okay, so we know our bounds are from 0 to 2. Now, let's work through this. If we're going to rotate around the y-axis, then our radius is going to be x. Our height, we want upper minus lower. Upper function is 8. Lower function is x cubed in this area of this region. So let's find volume, 2 pi times integral from 0 to 2 of x times 8 minus x cubed. So again, I'm going to put this in without the pi. We'll add that in later or multiply that in later so that we can get both versions. X times 8 minus x cubed, comma x, comma 0, comma 2. And that gives us 19.2, which as a fraction is 96 over 5. So we have 96 pi over 5. Okay, as a decimal, let's find that just in case. So we practice both. That gives us 60.319. Okay, now let's find the volume. If we rotate around the line x equals 4, this is going to look really similar, but remember, radius is now going to be 4 minus x. Height will be the same, 8 minus x cubed. So it's going to be a little bit tougher to type in. We will have 2 sets of parentheses because we're going to have 4 minus x times 8 minus x cubed. Okay, notice our bounds do not change. Just like before, the bounds are not going to change just because we changed the line we're rotating around because that area is still contained between 0 and 2. So if we put this in 2 times the integral of 4 minus x times, oops, I forgot my parentheses, times 8 minus x cubed, comma x, comma 0, comma 2. That gives us 76.8, which as a decimal is 384 over 5. So this is 384 pi over 5. I don't know if I said as a decimal. I meant as a fraction. As a decimal, we're going to multiply by pi, and that would be 241.274. Guys, remember, if you are leaving an answer in decimal form, you always want to round to the third decimal place. If we're talking on the AP exam, if it's a free response question, you're not going to get the answer. You're not going to get the point for the answer if you do not have those 3 decimal places. Make sure that you are taking care of that and using the correct decimal places. All right, let's take a look. Now we're going to kind of combine. Okay, we're going to look at the same region for all four of these, but we're going to be doing some vertical rotation, some horizontal rotation. So we're going to have a mix of our disc washer and shell method. So let's figure out what kind of region we're looking at first. Okay, it's first quadrant region, and it's bounded by the graphs of y equals x cubed and sine of x. So x cubed we know comes down and whooshes kind of like that. Sine of x starts at 0. Looks kind of like that. So we're looking at area between these two functions. Now we've got to figure out where they are equal to each other. Okay, we know that they'd be equal to each other at 0. Okay, 0 cubed is 0, sine of 0 is 0. We know they're equal at 0, but we need to find out what this value is. I'm going to call it A because that's going to make it easy to refer to it in our integrals from here on out. And just as an FYI, if you're doing, say, a free response question on the AP exam and for anything in our course, if you have a problem like this where you have a long decimal where these things intersect, you can refer to that as long as you specify what that value is. If you say, you know, A equals and you put the number, you can then use A anywhere in that problem in your integrals and you have specified what that value is, so you can use it at that point. So keep that in mind. That can help a lot with your notation. It can help kind of keep it clean so that you're not having to write out a long decimal every single time that you write out the integral. Especially for ones like this where you're doing multiple parts and you might be using that number over and over. Okay. All right, let's go find that. First of all, I am in radian mode. Good. So let's go try to plot this. We've got x cubed and we've got sine of x. Okay, we need to go find where these two are equal to each other. We may want to zoom in, so I'm going to play with my window a little bit. We know we're only in the first quadrant, so I'm just going to go from -1 to 5 for each of these, and that might help a little bit. Zoom it in. Okay, now we're looking a little bit better. Okay, so what we can do is hit second trace, and that goes to the calc menu. Let's find the intersection point. Let's come back down and see where we are. There we go. Guess. You don't have to. Oh, Lord. Where'd I go? Oh, my goodness. Okay. You don't have to guess. So we got points. Let's write that down. This is our point A. 0.92862631. Okay. Guys, I will tell you, I do not like to round early. Sometimes you're totally fine to round early, but sometimes it can throw off your answers. And so I like to be as precise as possible. So I go as many decimal places as they give me, and that's what I type in. Now in your 89, you can actually copy a value. So if you can actually store it as a value as well. So you can either copy it or you can store it. And so if you want some help with that, please feel free to ask me. Just as another note on your TI-89, I would not try to use the solve key because remember that sign is periodic. So sometimes it will not give you the correct answer or it will just give you a multiple. So just be careful when you're trying to solve using trig. I usually use the graph for that. This one, I think they only intersect at 2 points, so you might get the correct answer. I would just be careful, okay? I kind of, as a rule of thumb, anytime I'm solving trig, I usually use the graph just to be sure. All right, let's go back. So now we want to rotate around the x-axis. We want to find that volume. Okay, if we rotate around the x-axis, we are definitely going to have some empty space, so we are using washer. We need to know what is our big R and what's our little r. Big R, again, from line of rotation to the furthest part away of the area that we're rotating, okay, would be going up to the sine of x function. So big R is sine of x. Little r, distance from line of rotation to the closer part, would be x cubed. So our volume here, using washer, would be pi times integral from 0 to that a number, of sine of x squared minus x cubed squared. All right, let's go. I'm going to leave the pi off again. I'll add it in. Let's get the integral of sine of x squared minus x cubed squared would be x to the 6th. So I'm just going to go ahead and do that, make it a little bit easier. Comma x, comma 0, comma 0.9286261. Okay, so that gives us 0.193. Okay, we're going to need a decimal anyway, so I can just go and multiply by pi. I usually would not leave my answer as 0.139 pi. Pretty much never do that, so just go ahead and get the decimal, which would be 0.438. Okay, I had forgotten the fact that we have a decimal in our bounds. We're going to get a decimal answer anyway, so we don't have to worry about leaving off the pi from now on. All right, now let's go around the y-axis for part B. If we're going around the y-axis, that is a shell method problem. We need the radius, which would be x, the height, upper minus lower, be sine of x minus x cubed. So we have 2 pi, since it's shell method, times integral from 0 to a of x times sine of x minus x cubed. Okay, let's go type that in. 2 pi times the integral of x times sine of x minus x cubed, comma x. Oops, didn't get my comma, did I? Comma x, comma 0, comma, and then we have 0.92862631. Okay, so that gives us volume of 0.669. Okay, now let's try the next one. Now we're going to rotate around the line y equals 3. Okay, if we're going around y equals 3, that's a horizontal line, and we're going to have to use washer method. Okay, so think about your line y equals 3 somewhere up here. So if we're going around the line y equals 3, our big R would be from the line of rotation to the furthest part away, we would be taking 3 minus x cubed. And little r, from the line of rotation to the closer part, we would be taking 3 minus sine of x. So volume here is going to be pi times integral from 0 to a of 3 minus x cubed all squared minus 3 minus sine of x all squared. Okay, if we go to type that in, we need pi times the integral of 3 minus x cubed all squared minus 3 minus sine of x all squared, comma x, comma 0, comma 0.92862631. And that gives us 3.618. Okay. Let's see, let's move down a little bit here. All right. Last one. Let's find the volume if we rotate around the vertical line x equals 2. So now we're going around vertical line. That means we're using shell method. We need our radius, which would be 2 minus x. Our height would still be the same as it was before, sine of x minus x cubed. Okay, so we have 2 pi, since this is shell method, integral from 0 to that point A of 2 minus x, minus, times sine of x minus x cubed dx. Let's go find that volume. So we have, whoops, not 1, 2 pi times our integral of, 2 minus x times sine of x, oops, minus x cubed, comma x, comma 0, comma point, what was it, 92862631. And that gives us 2.035. Wow, that doesn't look like a 2. Let's fix that. All right, guys. Hopefully this has been helpful looking through these two different methods as well. At the end, we kind of mix them together. You can start to see when you use which one. It is very convenient to use shell method. Shell method is actually not in the curriculum anymore for AP Calc. However, if you see one where you're rotating around a vertical line, you are still allowed to use shell method. You can always, they will always accept that work for the free response. If you try to use disc or washer method and you are rotating around a vertical line, you just have to get everything in terms of Y and then use disc or washer. That's why I prefer shell method, because it's a lot easier to keep things in terms of X, because that's normally how we have our equations set up anyway.